This is the solution video for section 9.2, problem number 1. All right, so a particle moves along the x-axis so that at any time t greater than or equal to 0, its acceleration is given by a of t equals the natural log of the square root of 3 plus t squared. If the velocity of the particle is 4 at t equals 2, what is the velocity at t equals 3? All right, so we're given a of t, right? Now, we know that a is the derivative of velocity, right? So the derivative of v of t dt, right? So if I wanted to find v of t, right, I'm going to have to separate the variables, right? So dv of t dt equals the natural log of the square root of 3 plus t squared, right? And then we're going to have to integrate, right? Oh, sorry, dt. Then we're going to have to integrate. Now, what we need to realize is that we cannot integrate the natural log of the square root of 3 plus t squared because a u substitution would not work, right? And so this is where we need to turn this into a fundamental theorem of calculus problem. So we're going to integrate the natural log of the square root of 3 plus t squared with respect to t, but we have to do it from t equals 2 to t equals 3, right? And so what we learned in unit 7 is when I integrate this acceleration, I'm going to get velocity, and it's going to be evaluated at velocity of 3 minus the velocity at 2, right? And so what this integral actually represents is the change in velocity from 2 to 3, right? And so now we can calculate this with our calculator. We can get that number. All right. We want to know V of 3, and we know that V of 2 is 4, right? And so then once we do that calculation, we have a relatively easy equation to solve. So I'm going to leave this blank for a second. But in order to solve for V of 3, we're going to take that calculated value, and then we're going to add 4 to it, right? And that's going to get us the approximate velocity at 3. All right. And so let's calculate this natural log of the square root of 3 plus t squared. All right, so calculator. All right, so we're going to integrate. So math 9 from 2 to 3. All right, and it's the natural log of the square root of 3 plus x squared, right? And then close parentheses on the natural log. So let's just make sure I have it right. Integral from 2 to 3, natural log of the square root of 3 plus x squared. All right. And then we're integrating that with respect to x. All right. And so now we calculate this value, right? We get 1.111. All right. 1.111. All right, and so this integral is approximately 1.111, and so we're going to take 1.111 and add 4 to it, so we get 5.111, right? So now, remember what this is, well, this would be the velocity, right? So if acceleration was in like meters per second squared, then this would be in meters per second, all right? So remember, when we integrate like in this case, acceleration, right? So let's say it was meters per second squared. When we integrate with respect to time, we're multiplying by that unit of time, right? And so then we're going to end up with a velocity like meters per second. All right. And so that is problem number 1.